Okay, today we're going to talk about literal equations. And now, literal equations are um, come into a situation where if we have a formula, for example, and the formula is looking for one specific unknown, but we know that unknown, and we're looking for a different unknown, it may be beneficial for us to be able to rewrite that equation in such a way that it um, rewrite it in such a way that our focus is on the unknown that we're looking for rather than the one that we already know. Okay. Sorry, I know that didn't make a lot of sense, but it will here in just a minute. I'll show you a few examples. So right now, a literal equation is an equation with multiple variables. Okay, and we're not looking for an actual solution here. Our job is just to rewrite or reconfigure this equation so that it's in a different order. So that a different unknown is the focus point rather than the one that we're given. And so you will have a study island on this, so we get some extra practice. This is something that takes a little bit of work and some practice to kind of work your way through it. But we treat these exactly as if they were numbers, okay? So here's what I'm going to show you. I'm going to show you again just an easy two-step equation and how we would solve it. So remember, our first step is going to be to add the 5. And 2x is equal to 18. And then we're going to divide by the 2, and x is equal to 9. Okay? Now, a literal equation is that same equation, but written all in variables. So we treat it the same way. We're just not going to be able to simplify it to a final number answer. So just like we added the 5 over here, we're going to add the b first. And so we have ax left on the left is equal to c plus b. And then we're still wanting x to be our focus on the left, so we're going to divide by a. And so x is equal to c plus b over a. And that's as simplified as we can make it. Whereas over here, we will be able to simplify it to the number 9. Over here, I don't have any numbers, so I'm going to have to just simplify it the best that I can. And so x is equal to c plus b over a. Okay? So, a couple things. One thing that is similar, okay, similar between the two, is that both use opposite operations to isolate variables. Okay, so as we're looking for a variable, we're going to be using those opposite operations. So for example, this was a negative, so to get rid of it, we added it, right? Same thing over here. It was a subtraction, so we added it to get rid of it. Difference is that the literal equation, that's the one on the right, doesn't simplify nicely. And it's because there are multiple variables due to multiple variables. Whereas this only has one variable and we can kind of condense everything into a variable and a number. Over here, we're going to have to keep those variables because we don't know what they are. And I can't simplify them. I can't add a c and a b together because I don't know what c is and I don't know what b is. Okay? And so they're just going to have kind of a messy looking answer sometimes. So here's what I mean when we're talking about formulas. So look at number 1. 1 is the area formula. Area is equal to length times width. Well, what if I know the area of the room, but I'm looking for the width of the room? Okay, so I can rearrange this equation to make it easier to use. So if I want to get W by itself, okay, it says solve for W. If I want to get W by itself, well, it's being multiplied by L. So to get rid of that multiplication, I use the opposite operation, which is division. So I can divide by L. So on this side, okay, it'll go away, and I'll be left with W. On the right side, I can't simplify that any further. So I'm going to have area divided by length. So if I know the area and the length of a room, and I'm looking for the width, okay, I can just divide the area divided by the length to find the width. So I've just rearranged that formula to make it a little bit easier. All right, and there are several equations just like that. So D equals RT, V equals LWH. Okay, this is the distance formula. This is the volume formula. There are plenty of formulas out there that you might have a reason to do some rearranging. Okay, so I'm going to show you just a couple of others. And this one is going to be very similar, so we're going to skip it and go to number 5. Number 5, we're looking for H. So to get H by itself, okay, we got to use some opposite operations. So I'm multiplying H by W and L. So to get rid of that, to undo it, I'm going to divide by W and L. And I can actually divide them all at once just to make it a little easier. So those are going to become 1 over here and be left with H. And on the left side, I'm going to have V divided by LW. And that's as simple as I can make it. I just leave it as is. And so I have solved for H. All right, another example of this, we're solving for C this time. So I want to get C by itself. Well, right now I'm subtracting S from C. So to undo that, I'm going to add S to this side. I'm going to add it over here. And so what I'm left with is C is equal to M plus S. And I can't combine those any further, so I know that I'm finished. Okay, so you're going to be working on the evens on these today. So 2, 4, 6, and 8. All right, so those are pretty simple, and you can take your time and work through those. And then we're going to do some multi-step problems on the back side. In just a minute. So I'm going to pause this video. You can finish working on those, that 2, 4, 6, and 8. Send them to me if you need me to look at them. I'll be glad to do that. And we're going to go ahead and get started on the next video on some multi-step problems.